Hello everyone, welcome back. This is Engineer Hussein. What's up, P? So in this video, we'll be looking at the question I was presented. So this is one of the many physics problems that you might come across. So let's try and solve it. So before we begin, do not forget to like and subscribe. Okay, so it says a particle starts from rest. So let's always get some information from whatever that we have. So it says that a particle starts from rest. So this basically tells you that the initial velocity is 0. Yeah, let's just see maybe that's what this information I picked to be even useful. So a particle starts from rest and accelerates as shown in the figure. So A wants us to determine the particle speed at different time intervals. Okay, so 10 and 20. Okay, so basically for this one, I think the easiest way we can there are actually two methods we can solve this, but I'll just explain the easiest method because I feel like that's one of the things you should always remember. If you look at this is called the acceleration time graph. So whenever you see like straight lines, in this case, be mindful that's an acceleration time graph. For a velocity time graph, there will always be like slanted lines like that. For speed, it will be like horizontal lines or vertical, horizontal, no, be no slant line attached to it. So be mindful. Velocity is the only one that has slant lines. Speed and acceleration has vertical and horizontal lines. So what you have to know is this, that the area under the graph of the acceleration time graph represents the speed you need. So the area is the speed. So you have two shapes, you have shape A and shape B. So you want to find the speed at time is equal to what? 10 seconds. So from the initial to 10, that's the speed you want. So we know that speed will be equal to the area of shape A, which is L times B. The length is 10, then the breadth is 2. So we have the speed of 20 meters per second. So I've solved for the first portion. Then our time is equal to 20 seconds. So as you can see, you want at time is equal to 20. So at time is equal to 20 from the origin, what shape do we have? I can combine shape A and shape B to get what I need now. But shape B alone will give me what I want. Because at the 20 region, because if from 0 to 10, I'm having my speed to be equivalent to 20 meters per second. Then again, from 10 to 15, I'm having nothing. So there the velocity, or this is the speed, will be 0. And again, from 15 to 20, I'm having the B, which is what I need now. So this will be a case where I say speed is equal to L times B. And then I'll say L, which is the length. So it will be like 20 minus 15. Basically give me 5. Then times the breadth, which would be the minus 3 at the bottom, because that will represent like the height now. And this will give us like minus 15 meters per second. So basically this will be the speed. Then B says the distance traveled in 20 seconds. So now for us to find the distance traveled in 20 seconds, all we have to do is to draw a velocity time graph. So let's draw a velocity time graph. This is time. I don't know why these things are always fighting. Velocity fighting with time. I don't know a big deal about time. But look, so velocity versus time graph. So what we do is this. We basically know that since we want to find the distance, okay, let me just draw like a small shape so that I can save up some space. Okay, so we know that we have from 0. Let's see what was going on. So this is the velocity now, isn't it? And then this is the time. So the velocity is in meters per second. The time is second. Okay, so from 0 to 10, what happened? The velocity increased to 20. So you can put up 20 there. So from 0 to 20. There. And this happened in the time, what was this? 0 to 10. I had that, which is 20. So from 0 to what? to 10 seconds. And then from 10 seconds to 15 seconds, the velocity was constant. So the velocity was constant. And then from 15 to 20, the velocity dropped. So from this point, it has to drop to minus 15. So if I say 20 minus 15, that will give me 5. So it dropped to 5 meters per second to that point there. And this is time 20. Now you need to define the distance. Remember, the area under the acceleration time graph gives you the velocity. So for me to find the distance, I need to find the area and the velocity, which gives me the distance. So I have shape A, shape B, C, and this small one here, D. So what I have to find is the area. So shape A, we know this is half base times height. So it's half. The base is 10, the height is 20. So we have A given, this cancels with that. So I have 10 times 10, that's 100 meters. For shape B, I'm having L times B, which gives me the difference here, which is 5 times the height 20, basically gives me about 100 meters again. Then I can move on to C, is half base times height. So I say half of the base, which is here, the difference there, which will be 5. Then the height is from here to the top there, which will be the difference in these points, which will give me 15. And if you compute this, it basically has to give you 37.5 meters. Then D, small shape here, you have L times B, which gives you the difference of L, which gives you 5, and the height from this point to that point, which is also 5, basically giving you 25 meters. So to find the distance, all you have to do is to add up all the areas. 100 plus 100 plus 37.5 plus 25. Therefore, the distance in the first 20 seconds will basically give you 262.5 meters. And that's the distance. Alright, so I know most of these problems at first glance, there might be a handful, but trust me, if you try to go through them over and over again, you'll get a hang of it and you realize that they were not even that much of a big deal. So just try to watch the videos over and over again at some point and you get a hang of it. Alright, so thanks for watching. If you have queries, you can reach me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress. And don't forget to strategize before you become a statistic. Try to push for that A+.